Today, we are going way beyond just storing data. We're going to dive deep into advanced MySQL automation and completely transform your database from, a passive filing cabinet into an intelligent, active partner. So let me ask you a question. Think about your database right now. Is it just a dumb box, a place you shove data into and just kind of hope it's still there when you come back for it later?
Well, today, that all changes. We are going to give that database a serious upgrade. We're talking about evolving it from a simple tool into an active, intelligent system. We're literally giving it a brain that can think and reflexes that let it act on its own.
This whole journey is about that evolution, moving from being just a place for storage to becoming a complete system. You see, the big shift here is from passive to active. Most databases, they just sit there, waiting for you to tell them what to do. We're building one that works for us, using its own internal logic to automate tasks, validate data, and enforce really complex business rules all by itself. So, let's kick things off with our first upgrade. Normally, when you run a query, it just dumps all the results on you at once. But what if you need to be more surgical? What if you need to handle your data one piece at a time, row by painstakingly row? That, my friends, is where a cursor comes in. The best way to think about it is like a librarian carefully reading a book line by line. A cursor is a pointer that lets you step through your query results one single row at a time. And this is absolutely critical when you need to do complex things that a simple update command just can't handle, like calculating a running total or calling some other process for every single record. So, how do you use one? Well, it follows a really logical life cycle. First, you declare your query. That's what defines your data set. Then you open it up to start the stream. You fetch the first row into your variables, you loop through all the rest, and then, super important, you close the stream to clean everything up. It's a precise 5-step dance. And I cannot stress this enough, you need a safety net inside that loop. The continue handler for a not found condition, that is your emergency brake. It's what tells the loop, hey, we're out of rows, it's time to stop. Without it, you create a really nasty infinite loop that can and will bring your server to its knees. Okay, so now our database can process data with real precision. For a second upgrade, we're going to give it a brain. We're talking about building reusable intelligence right inside the database itself. First up, we've got the MySQL function. Just think of it like a handy pocket calculator for your database. It's this reusable chunk of code that takes in some values, does a calculation like, say, averaging a few numbers or properly formatting a person's name, and it returns exactly one single value. That's it. Simple, clean, and really efficient. And then we have the stored procedure. This is the heavy lifter. It's a pre-compiled set of commands that can handle way more complex, multi-step jobs. It can modify data, and it can even call itself, which is a process called recursion. For example, imagine calculating the entire chain of command above one employee all the way up to the CEO. That's a perfect job for a recursive procedure. But with great power comes, well, a serious warning. An infinite recursive loop is a fast track to crashing your server by eating up all its memory. That's exactly why MySQL has a built-in safety switch, max_sp_recursion depth. And here's the kicker. Its default value is often 0, which means recursion is turned off. You have to consciously enable it and set a safe limit before you can even use it. So how do you know which one to pick? This table breaks it down perfectly. Functions must return a single value, and you use them right inside a select statement. Procedures, on the other hand, can return values, but they don't have to, and you execute them with a call command. And here's the biggest difference of all. Functions are basically read-only, whereas procedures are allowed to use DML, data manipulation language, to insert, update, or delete data. All right, we've given our database precision and intelligence. For our third and final upgrade, we're giving it reflexes. We're going to make it automatic. And this is where triggers come into play. A trigger is a special kind of code that you don't call yourself. Instead, it fires all on its own whenever a specific event happens to a table, an insert, an update, or a delete. The best way to think of it is as your database's own personal security guard, always on watch. So what does the security guard do all day? Well, its job is to keep things in order. It can create audit trails to log every single change. It can validate data before it even gets saved. It can stop common user mistakes in their tracks.
And it can enforce complex business rules that a simple column check could never dream of, like a rule that says a customer can't place a new order if their account is overdue. That's a perfect job for a trigger.
Let's watch this in action. Imagine a user just runs this simple command to give an employee a raise. Seems pretty standard, right? But behind the scenes, bam! A new row instantly pops up in a completely separate audit log table detailing who made the change to what and when. That is the magic of an after update trigger. It waited for the change to happen, then it swooped in and logged it. And the best part, the application code didn't have to do a thing. Okay, so logging is great, but what about stopping bad data from getting in to begin with? What if someone tries to do something silly, like set a salary to a negative number? Well, this is where a before trigger becomes your first line of defense. To pull this off, triggers use two special keywords, old and new. And it's actually really simple to understand. Old refers to the data as it was before the change. It's the past. New refers to the incoming data that's being proposed. It's the future. So a before trigger can look at the new.salary value, see that it's negative, and then either reject the whole update outright, or maybe even fix the value, setting it to 0 before it ever gets written to the table. So let's step back for a second. After all these upgrades, what have we actually built? Let's take a look at the payoff, because we've created a truly smart database. It all comes together like this. Cursors gave our database the power to process data methodically. Functions and procedures gave it reusable intelligence. And triggers gave it automated reflexes. See? It's no longer just a box for data. It's a complete, self-regulating system. And that is the ultimate takeaway here. You're not just a data janitor anymore, just storing and fetching stuff. You're now an architect, building intelligent systems that can protect, manage, and automate themselves. So I'll leave you with this one final thought. You've just seen how to give your database a brain. The only question left is, what roles are you going to teach it first?